Hi everyone, welcome back. Let's go over the problem. Does the period of a pendulum depend on the length of the string, the pendulum's mass, or the pendulum's amplitude? Alright, let's go over some terminology. Displacement is measured from the point of equilibrium. It's delta x. Amplitude is the maximum displacement. That's equivalent to the radius r in uniform circular motion. A cycle is a full to and fro motion. This is the same as one trip around a circle in uniform circular motion. Period is the time required to complete one cycle, and frequency is the number of cycles completed per second. Alright, so let's go over the energy components of each pendulum. When the pendulum is at the lowest point, kinetic energy is at a maximum, and gravitational potential energy is zero. When the pendulum is at its highest point, gravitational potential energy is maximum, but kinetic energy is zero. Due to no outside forces acting upon the scenario, the energy total is equal to gravitational potential energy plus kinetic energy. The equation for period of a string pendulum is 2 pi the square root of L over G, and the frequency is equal to 1 over 2 pi times the square root of G over L. Alright, let's return back to the problem. Does the period of a pendulum depend on the length of the string, the pendulum's mass, or the pendulum's amplitude? We'll answer this in this following lab. For this lab, you will need a stander support, a string, a bob, and an arc of pendulum. So let's start off. If the spring length remains constant, but the mass of the hanging object is changed, what happens? Also, let's see if the mass of the hanging object remains constant, but the length of the string is changed. So what did we see? We saw that the period of a spring pendulum is dependent on the length of the string. The period is not dependent on the mass of the hanging object or the amplitude of the pendulum. For questions on simple harmonic motion, please visit www.njctl.org. Thank you for participating in this online lab. I'll see you next time.